Good afternoon, my fabulous chemistry students. Mr. Milks here for another installment of lecture videos for Unit 1. If you are watching today's lecture, I am guessing you are on page 14 and 15. Today we are going to delve into the world of dimensional analysis. This particular form of unit conversion is a little bit more complex, so I'm going to take my time and make sure we work our way through it. Notice at the top that we're going to convert 6 centimeters to kilometers. Now we could use the King-Henry method for this, but I want to teach you the long, drawn-out math way in case we have to convert something more complex in the future. Okay? So step number 1, it says write the term that will be converted in both number and units. So in the problem we have 6 centimeters. Step number 2, it says write the conversion formula. Well, I got to get from centimeters to kilometers, and there's no one-step solution for that. So we have to do it in 2 steps. I can get from centimeters to meters, and I can get from meters to kilometers. So I have 2 conversions I have to do in this particular problem. Number 3 says make a fraction such that the denominator of the units are set up as the same in step 1. So I'm going to bring the units right down from step 1 so I know which way I'm going to go. I'm going to start in centimeters. And now I have to take this first equality, 100 centimeters equals 1 meter, and I have to set it up in such a way that the centimeters are in the denominator. Now I could set it up like this, but that would not satisfy the centimeters in the denominator. If I were to multiply these two together, I would get centimeters squared over meters, and that is just a mess to deal with units, and that's not what I'm looking for. I want these things to cancel out. So if I flip this thing and I make it meters over centimeters, when I'm all said and done with the math, the centimeters are going to cancel out nicely and take me to meters. So now I'm going to be in meters. I need to make it so that the kilometers and meters equality fits the same description. So I don't want kilometers in the denominator. I want meters in the denominator so that the kilometers is all that's left. So I need to flip this equality because either or, it could be either or depending on what I'm in. Right now I need to, step 4, multiply all of these together. So I'm going to take my 6 centimeters, I'm going to multiply it by my first equality, and then multiply it by my second equality. Now before I get too much farther, notice this multiplication sign is not an equal sign. So I'm not cross multiplying. When I multiply fractions, I'm going to multiply all the numerators and then divide by all the denominators. Okay? So if I set this thing up, my units are going to cancel. Centimeters is going to cancel with centimeters. Meters is going to cancel with meters and leave me just the unit I want, which is kilometers. In the calculator, it's going to be 6 times 1 times 1 divided by 100 times 1,000. Make sure you put parentheses around the numerator or hit equals before you do such a thing in the calculator, or you will very much confuse it. I have kilometers left, and my number is 0.00006 kilometers as my answer. Okay? Deep breath. It's okay. We can do some more though. So let's see what else we can come up with. Some additional notes on dimensional analysis. Some of the very common conversions we're going to see. Milliliters to liters. So if we start with 750 milliliters and I need to convert it to liters, I have a choice. I know a relationship between milliliters and liters is 1,000 milliliters for every liter. Now from the last problem, we learned we got to pick the right equality here. Do I want milliliters in the denominator? So I'm going to go ahead and pick the bottom one because milliliters is in the denominator. Now my units will cancel, and I can get an answer. In your calculator though, this is 750 times 1, which is 750, divided by 1,000, which leaves me 0.75 liters. Very good. Now that was a nice simple one. Let's try a little bit more complex one. Let's go from days into seconds. Okay, if I start with 2 days, I can convert days into hours. I know there's 24 hours in a day, but which way am I going to use this equality? I need to set it up in such a way that days are in the denominator, so I'm going to use the top one. And when I do that, the days will cancel. Now I'm into hours. So I know something about hours and minutes, don't I? I know that there's 60 minutes in every hour, but again, I have to decide which of these fractions I'm going to use. Now I'm in hours, so I want to take the bottom one now because I see hours in the denominator per our rule from the last page. And if I do that, the hours are going to cancel out. Now I'm left in minutes, but the problem wants to get me all the way to seconds. So now I have to know something about minutes and seconds. There's 6 seconds in a minute. I just got to figure out which fraction I'm going to use. In this case, I want minutes in the denominator, so I'm going to use the top fraction. Now my minutes will cancel. Now I'm left in seconds, and now I have some calculator stuff to do. The way this is going to work in the calculator, I'm going to have 2 times 24 times 60 times 60. That is me multiplying my numerators across. My denominators in this case are all 1. Isn't that very nice? So anything divided by 1 is itself, and I simply get an answer of 172,800 seconds. So what we just did was a quick example from milliliters to liters using dimensional analysis where you could actually use King Henry method. And in the second one, we did days to seconds. And King Henry method isn't really going to work for that. It's a little bit more drawn out. Now, I don't want you to be too overwhelmed that I did 3 conversions all at once. If you decided and needed to just come up with an answer here, like let's say 2 days times 24 hours is 48 hours, and then multiply by another fraction, you can of course do that. And it's going to just take a little bit of practice, and I think you'll get a little bit more accustomed to how the system works. As long as you follow your units, you're going to be okay. That's pretty much the rule of thumb. So if you're still having trouble with conversions, again, there is no limit to the amount of problems you can find out there. I need you to seek out problems and take it upon yourself to really hammer this home so you can, of course, not get any wrong. Keep doing them and keep doing them till you can't get any wrong. And if you need any help, by all means, I'll be here. See you guys tomorrow in class.